What does a space rock from another star teach us? Quite a lot, it turns out. Welcome to Shooting Star News. This is our edition from the Crystal Earth podcast, and I'm your host, Nick Sconia. Today we're diving into the latest interstellar visitor making headlines. It's officially named 3I Atlas, and it's only the third object ever observed entering our solar system from beyond. We'll explore today in what we know about this new celestial guest, how it was discovered, its path through our neighborhood, and its physical traits. And we'll compare it to the two other interstellar wanderers that came before, the mysterious Oumuamua in 2017 and Comet 2I Borisov in 2019. Along the way, we'll see why each of these cosmic visitors has scientists so excited and what they reveal about the wider galaxy. So strap in for a journey from one star system to another, right from the comfort of home. Meet Interstellar Comet 3I Atlas. On July 1st, 2025, very recently, astronomers in Chile spotted something unusual moving against the stars. The discovery was made by the Atlas Survey Telescope, part of NASA's Asteroid Terrestrial Impact Last Alert System, ATLAS. And initially, it logged it as a minor planet center as a new object. Very quickly, its path through space raised eyebrows. Instead of orbiting the sun like normal comets or asteroids, this object was on a one-way trip, a hyperbolic trajectory, indicating it came from outside our solar system. In other words, this was an interstellar comet passing through. It has since been formally designated 3I Atlas, marking it as the third interstellar object, 3I, and crediting the Atlas Survey for its discovery. At first glance, through telescopes, 3I Atlas looks like a fuzzy comet. It sports a surrounding cloud of dust and gas, a coma, indicating that it has an icy nucleus, which is warming and releasing material as it approaches the sun. In late July 2025, the Hubble Space Telescope snapped a detailed image of 3I Atlas, revealing a teardrop-shaped cocoon of dust being shed from the solid nucleus. In Hubble's long exposure, the comet was tracked as it moved, so background stars appear as streaks in this picture. And it's a vivid illustration of just how fast this object is moving. From the Hubble data, astronomers estimate the comet's nucleus is at about 5 to 6 kilometers across, and it could be significantly smaller, perhaps as little as a few hundred meters. That size estimate is still imprecise, but it suggests 3I Atlas is not a gigantic object. It's likely on the order of a few kilometers or less, which is in the same ballpark as many known comets. In terms of speed and trajectory, 3I Atlas is zipping along at a remarkable pace. When we first observed it in July, it was already moving about 137,000 miles per hour. Relative to the sun, and it's accelerating as it falls inward towards the sun. It's currently inbound toward the inner solar system and will reach its closest point to the sun, the perihelion, around October 30th. So this will be a Halloween visitor for us. At that time, it will pass just inside the orbit of Mars, roughly 1.4 astronomical units from the sun, about 130 million miles. This seems far, but astronomically it's not. Importantly, 3I Atlas poses no danger to Earth. Its path keeps it quite far from us, never coming nearer than about 1.6 to 1.8 astronomical units. Well beyond Earth's orbit, to 150 to 170 million miles. So there's no risk of impact. This is purely a spectator event for our planet. And, of course, gives us a lot of opportunities to learn about interstellar space. Astronomers worldwide are racing to observe 3I Atlas during the window of time it's visible. Currently, the comet can be seen with sizable telescopes and should remain observable through around September 2025. After that, it will get difficult to see as it passes behind the Sun from our viewpoint. By early December 2025, 3I Atlas will emerge from the Sun's glare, allowing another round of observations as it heads back out to interstellar space. Scientists are eager to use this opportunity to study the comet's composition, rotation, and other properties. Every bit of data is precious because once 3I Atlas swings past the Sun, it will never return. The Sun's gravity isn't holding it, so it will continue cruising into the darkness of interstellar space, gone forever from our solar system. One natural question is, where did 3I Atlas come from? Right now, we can't pinpoint a specific star, but we know its general incoming direction. It approached from the constellation Sagittarius, which happens to line up with the dense central region of the Milky Way galaxy. That suggests 3I Atlas may hail from somewhere in the Milky Way's thin disk, possibly a star system nearer to the galactic center. But that's an educated guess. Nobody really knows. What's certain is that 3I Atlas formed around another star and was somehow thrown out of its original planetary system long ago. Perhaps the star imploded, and that force sent it flying at the speed at which it's going. It has spent millions, maybe billions of years drifting through the interstellar void before fatefully crossing paths with our Sun. In essence, it's a messenger from a distant star, carrying chemical and physical clues about its home, far beyond our reach. Before we talk about those clues and why they matter, let's put 3I Atlas in context. We've said it's the third known interstellar object, so let's rewind a bit and revisit the first two, because their stories are fascinating and quite different from each other. Meet Oumuamua and 2I Borisov, the predecessors of Atlas, on the interstellar stage. The story begins in October 2017 with the discovery of Oumuamua, officially 1I 2017 U1. Oumuamua holds the distinction of being the first confirmed object from another star system ever detected in ours. It was spotted by the Pan-STARRS 1 survey telescope in Hawaii on October 19th, 2017. The name Oumuamua is Hawaiian, meaning a messenger from afar, arriving first. A fitting moniker for this cosmic herald. And what a strange messenger it turned out to be. Unlike 3I Atlas, Oumuamua showed no signs of a coma or tail. There was no fuzzy cloud of gas around it. It appeared as a point of light, like an asteroid. And initial observations indeed classified it as an asteroid. But as astronomers tracked it, they noticed something odd. This object was accelerating slightly, as if a small extra force was acting on it. In our experience, that usually means a comet is outgassing or releasing vapor that gives it a tiny rocket-like push. Yet telescopes saw no vapor, no dust, nothing that looked like typical comet activity. To this day, Oumuamua defies easy categorization. Was it a very weird comet releasing difficult-to-detect gases, or a chunk of rock that just happened to get a nudge from something else? Scientists are still debating, but the prevailing thought is that it probably was some kind of desiccated comet or icy body that lost most of its volatiles. A few theories even speculated it could be an alien probe or artificial light sail. The issue with that is that it was the first of its kind, and speculations can abound. So we don't want to go too far into that direction, because the properties were very unusual, but there's no direct evidence for anything, while exotic, that couldn't potentially be a natural explanation. So we try not to jump, though it's fun to talk about it and discuss it in a way of possibilities. More, it's about its opportunities that we get off of these objects. What we do know about Oumuamua is derived from how its brightness changed as it tumbled through space. It didn't remain steady. It varied dramatically, suggesting it was an elongated tumbling shape. In fact, Oumuamua's brightness changes implied it could be up to 10 times as long as it was wide, with an estimated length around 400 meters or a quarter mile. Picture something shaped roughly like a cigar or maybe a pancake. There was even debate about whether it was rod-shaped or disc-shaped. Either way, its aspect ratio was higher than any asteroid or comet seen in our solar system. Truly a weird shape by our standards, by our knowledge. It's also somewhat reddish in color, similar to objects in the outer solar system, likely due to cosmic ray exposure, weathering its surface over immense time. Oumuamua passed extremely close to the Sun, only about 24 million miles away at closest, inside Mercury's orbit, and then shot back out. At its peak speed, it was moving about 196,000 miles per hour as it zipped past the Sun. By the time we found it, it was already past perihelion, its closest approach, and on its way out. So we had only a few weeks to observe it. It came from the direction of the star Vega in the constellation Lyra. Although it took so long to arrive, that Vega wasn't actually near that spot when Oumuamua was there, because we're talking hundreds of thousands of years. After swinging by, it headed off toward the constellation Pegasus, never again to return. Because it was discovered after its closest approach, we just caught it in time. And it was fading fast as it receded. This taught us that interstellar objects can be very challenging to catch. If our surveys blink, we might miss them. In fact, astronomers estimate that objects like Oumuamua might pass through the inner solar system about once per year on average. But they're usually small and faint, so earlier ones went unnoticed, of course. It's only in recent years with advanced survey telescopes that we can even have the ability to find these cosmic drop-ins, and my assessment is that there are many of these that come through, and that space is actually a pretty busy place when it comes to these objects. Now, fast forward 2 years from then to late August 2019, that's when the second interstellar visitor was spotted. And this one was much easier to recognize because it looked and behaved just like a normal comet. This was 2I Borisov, discovered on August 30th, 2019 by amateur astronomer Gennady Borisov using his custom-built telescope. Whereas Oumuamua was puzzling and could have been mistaken for a weird asteroid, Borisov was immediately identifiable as a comet. It had a visible coma and tail, meaning it was actively outgassing as it approached the Sun. In fact, one astronomer quipped that Oumuamua appeared to be a rock, but Borisov is really active, more like a normal comet. The contrast between the two was a puzzle. Why would the first interstellar object be inert and the second one be a gassy comet? It hinted that we were already seeing a diversity in these visitors, and I think we are going to continue that. Borisov followed a hyperbolic path through the solar system, clinching its interstellar origin just like Oumuamua did. It came nearest the Sun in December 2019, at a distance of about 2 AUs, around the distance of Mars's orbit, and then began its journey back out. But unlike Oumuamua, we discovered Borisov on its way in, which gave us several months to observe it under progressively better conditions. And scientists took full advantage. Borisov was studied by telescopes around the world, and even the Hubble Space Telescope kept an eye on it. Hubble images in late 2019 showed Borisov streaking through space at roughly 110,000 miles per hour. The comet was about 420 million kilometers from Earth at the time. In other words, pretty far, near Jupiter's distance. Yet Hubble could discern a bright central concentration of dust, the coma, around an unseen nucleus. The nucleus itself was too small to resolve, but from various observations, astronomers estimated Borisov's nucleus to be on the order of 1 kilometer to a half a kilometer in size. A NASA estimate put it around 975 meters across, roughly the length of 9 football fields placed end to end. So Borisov was a relatively small comet, comparable in size to many comets native to our solar system. Interestingly, in March 2020, observers saw Borisov's appearance change and realized a chunk of its nucleus had likely broken off. Even as an interstellar traveler, it was subject to the same volatile, fragile nature that many comets exhibit. Perhaps the most fascinating find about Comet Borisov was its composition. By looking at the light from its coma, scientists detected familiar gases like cyanide and water vapor, but also an unusually large amount of carbon monoxide. In fact, Borisov had a higher concentration of CO gas relative to water than any comet ever seen at a similar distance from the Sun. This was big news because carbon monoxide is a very volatile ice that typically only remains abundant if a comet formed in an extremely cold environment. This result, published in 2020, suggests that Comet Borisov may have formed in the chilly outer regions of its home star system, perhaps around a red dwarf star, which would have a colder protoplanetary disk. Another possibility is that Borisov is a fragment of a larger icy body, maybe a Pluto-like dwarf planet that got shattered, releasing a piece of it rich in carbon monoxide ice. Either way, the chemistry of Borisov hinted that not all planetary systems are alike. The ratios of gases in this comet were different from typical comets here, implying it was born under different conditions, as you would expect. Yet in other respects, Borisov was strikingly similar to comets of our own solar system. For example, its dust and general behavior were a good match. It even had a composition of dust grains and rock-forming elements that didn't scream alien so much as familiar when compared to our comets. It's as if Borisov said, "I might have grown up around another star, but I'm made of the stuff you'd recognize." This mix of familiar and foreign made 2I Borisov an incredibly informative visitor. To recap, in less than a decade, we went from 0 to 3 known interstellar objects. Here's a quick snapshot of these 3 cosmic interlopers and how they compare. 1I Oumuamua in 2017 was the first ever interstellar object detected. 400 meters long, very elongated shape, 10-to-1 aspect ratio. No coma or gases observed appeared to be inert, likely a rocky or metallic fragment with a reddened surface. Its exact nature is still debated, but it acted unlike any comet or asteroid seen before. 2I Borisov, 2019, was the first interstellar comet observed, roughly a half to 1 kilometer in size. It looked and behaved like a normal comet with a bright coma and tail, and its composition showed lots of carbon monoxide, more than in any similar local comet, suggesting it formed in a colder, possibly red dwarf star system. Essentially a typical comet from a atypical place. And then 3I Atlas, this year, 2025, newly discovered interstellar comet, and it is current. It appears active with an icy nucleus and dust halo. Preliminary size constraint from Hubble, somewhere between a few hundred meters, give or take, and it could be comparable to Oumuamua on the small end or larger than Borisov on the high end. Have yet to see. It's a little early. We need more data. It was detected inbound, which is fantastic for research, and will reach about 1.4 AU from the Sun in late 2025. And it's moving extremely fast. The 3 objects aren't much of a statistic, but already we see a range. 1 weird asteroid-like body and 2 cometary ones. This raises the question, why do scientists care so much about these interstellar interlopers? So let's talk about that. Why these cosmic visitors matter. Each interstellar object is far more than a fleeting curiosity. It's a direct sample of another star system's building blocks. Think about it. Everything else we've studied up close in astronomy, from planets to asteroids to comets, has been from our own solar system. Interstellar objects are fundamentally different because they formed around other suns. As one NASA scientist put it, An interstellar comet is like a chemical ambassador from a distant star, carrying a treasure trove of clues about worlds we may never be able to visit. We can't yet send spacecraft to exoplanets or scoop up material from around other stars. That's likely centuries away unless we develop something in the next few years. But when an object like 1 Oumuamua, or 2 Borisov, or 3 Atlas passes through, the universe has delivered a piece of another solar system right to our cosmic doorstep. It's an incredible opportunity for science. So let's break down a few key reasons these interstellar visitors are so significant. Comets and asteroidal fragments are essentially time capsules. In our solar system, comets preserve information about the early days of planet formation around the sun. Similarly, an interstellar comet preserves the chemistry and conditions of its original system's protoplanetary disk. By analyzing gases like water, CO, cyanide, etc., we learn what that object's home environment was like. For example, Borisov's carbon monoxide richness implies it came from an extremely cold region. That tells us that in some star systems, volatile ices can dominate, a clue to those stars' planet-forming processes. Oumuamua's dryness, no water or dust detected, hints it might be a leftover piece of a larger body, perhaps even a fragment of a planetary crust or something exotic like a nitrogen ice chunk from a Pluto-like world. Each visitor carries unique fingerprints of its formation, giving us a peek into another solar system's history. So as we conclude, let's reflect on the bigger picture here. In the span of 8 years, humanity has gone from wondering if interstellar objects even exist to having 3 on record, each unique, each teaching us something new. These cosmic wanderers are reminders that we live in a vast, dynamic galaxy. We're not isolated. Our sun is one star among hundreds of billions, trillions perhaps. And every so often, our paths intersect with debris from our stellar neighbors. It's a bit like finding a message in a bottle from a distant shore, except the bottle is a comet, and the shore is another star system. 3I Atlas, now inbound, is the latest messenger. By studying it, we're essentially opening a gift from a distant star. We don't know exactly what we'll learn yet. That's the thrill of discovery in real time. It could confirm things we saw with Borisov or surprise us in a whole new way. Either way, scientists will be poring over the data trying to decode what this interstellar comet tells us about its home. In a broader sense, these interstellar visitors kindle a sense of connection with the cosmos. As one space agency remarked, all the planets and comets in our solar system share a common origin, but an interstellar object is a true outsider, an immigrant from another stellar family. The fact we can study it with telescopes and glean information about another star's environment is astonishing. It's a preview of the science we'll do on interstellar journeys in the far, far future. Until we can send starships out there, the universe sends us a few samples, and we should cherish each one. The saga of 3I Atlas is still unfolding, and we'll be sure to keep you updated as we learn more about this traveler from afar. In the meantime, the tales of Oumuamua, Borisov, and now Atlas remind us that the cosmic ocean has currents that sometimes wash up unexpected treasures on our shores. Each interstellar visitor expands our knowledge and our imagination, reinforcing that we are part of something much greater. Who knows what the next one will be like? Perhaps in a year or 5 or 10, we'll be right back here talking about 4I, 5I, and beyond. New visitors, new lessons. And what I would like to say is that to expand that horizon, maybe we should be sending something to these visitors to attach to it so that our sensors can also travel interstellar before we can get there. Well, that's all for today's Shooting Star News. Keep looking up, keep wondering, and as the universe continues to drop by for surprise visits, we'll be here to share the story. After all, sometimes the universe comes to us, and isn't that a story worth telling? Until next time, my friends, be well.